converter task in which we are using a potentiometer to show the analog to digital converter value on LCD using V reference as 5. First of all, we are going to do the code. So, and then we will make the hardware according to the code, or you can make the hardware and then write the code accordingly. We are using Atmel Studio and C language for that. Go to the file section. Okay, here, go to the file section, go to new project and choose the C executable project. Here, renaming it according to the lab requirement, and here we need just click OK. After that, we are using Arduino Mega, so this one will be used. Okay, I have already taken the code from my lab report of lab 10, and I will be pasting the code here. Now let's if here we are basically defining the CPU and the clock threshold that is already there. It's 16 megahertz, so we have zeros here. Instead of mega, we are using 6 zeros. AVR input output library, delay library, and STD library for the LCD functions. We are using LCD data for LCD. We are using port B, and for the control we are using port C. Now, first of all, we are writing code for the LCD pins. This is the code for LCD pins where it will move to 1, and then we will have a delay of 1 second. Here, if it is, we are using in bit here, and it's not equal to this. So basically, we are using and equal operation here, and with delay of 100 seconds. After that, we are using unit 8T, which is 8-bit matrix. If the data is this, it will not display the pulse. However, if the data is this, we will see the pulse operatable, or it will send a signal. It is basically LCD based signals that what will happen on the LCD if certain signals are sent to it. Alright, after that you are doing this, that you are using the OR operation for both. Whatever option is coming, the LCD will show 15 minutes, 15 milliseconds delay. Then LCD will send data 000 depending on what kind of function or what kind of hex is being read. Next, set the LCD cursor. Whatever is displayed on the LCD, we are only using one row, so there will be one row only. The columns that we are using, all the columns that are present in the LCD, we are using all of that. So it is dependent on the LCD that you are using. You can change that accordingly. Or depending on how much column you have kept, the length and width of the characters can be adjusted as well. Now, the main code in which we are using ADC port as input, this is the port, that is why it is 00. For output port, we do FF, which means all of the B ports are acting as output, all of the C ports are acting as output. For the V reference, we have set ADMux to 040, and then we have set ADC enable and P. This is basically the prescaler value, which is 128 in this case, so it is set to 87. Now LCD is going to display the ADC value. This ADC value, here we have while loop. In the while loop, we are updating the ADC value, and this will clear the flag whenever the value will change. The minimum value of ADC is 1 and the maximum value is 1023, which is set between 2. So depending on the reference voltage you have given, V out by Vn, we solve this. And then we have LCD cursor, like what how you are displaying it on the LCD. It is basically to clear the print that is being displayed on there whenever you withdraw the output, and there's a delay of 200 milliseconds. Now based on this, we are going to create a hex file, build solution. Once the solution is built, we will debug it. Okay, now it's bugged. So start debugging and breaking. First of all, you need to select the simulator. Here we have the simulator. Restart the debug, and now it is debugged. So let's see the registers and input output pins. So first of all, this is the register and this is the main code. Let's reopen the registers. So whatever registers we are using, they will show output whenever we will step in. So register R17 is basically used, and this one, that is why they are 01. So in order to check which register is used when, we can step into here, use fn and f11 command. Usually these registers are used for the assembly language. For C language, we go for the input and output pins. Let's check the processor status. Processor status is giving a glitch. Wait a second. Okay. Tool debug win. Let's reset it. After the reset, let's go to the window and processor status. Okay, now this is the processor status. In the processor status, it is showing the Z, which means that, so let's step into and let's open the processor status. So you can see the processor status will change as we move onwards. So cycle count 258, FNF11, 259, 262. So depending on the command, the cycle count changes. And you can see earlier we didn't have any of these flags on. Now because of the delay and the value, the flags change. And let's stop debugging, again start the debug, and let's check the input output ports which are basically used here. F port is selected as input. We are going to see the output ports at in the moment. We can see all of them, but let's go turn by turn. For the B port, first of all, this is the B port. Go to debugging and step into. So when you step into it, all of these ports are selected on high. Now these ports do not have data in them at the moment, that is why they are shown below. Let's reset and select the port C and step into it. Okay, now when I will step forward, it will show that the B port is on. So here, see the DDR-C ports, all of them are on. Now they are not on at the moment, that is why they will turn blue. Okay, let's reset and check the port F. Port F will only be available on the input. Now it depends what input you are selecting. 00 means all the ports here are acting as inputs at the moment. Step into FNM and FNM. So usually when port is not specified, it does not give you a value there. Now let's make the Proteus of it. For the Proteus, we will create a new project. In the new project, from the development board, let's change the location here to desktop, new folder, and select folder. So we are using this one. Let's write and finish. Okay, first of all, according to the requirement, we're supposed to write the roll number and the name. Okay, this is a name that we are going to put at the top. Okay, now the things that we need are potentiometer that is active, weird, Wait a minute. Okay, we got the resource. The active potentiometer, and we need an LCD. This is the LCD that we are using. Okay, so now we know that we have selected B port as an output. So we are going to use these as output. Let's paste these here, and we need to adjust them there. Rotate clockwise. Rotate clockwise here. Um, Clockwise and clockwise. Okay, so pin 53 is connected to D0 from the start. Let's put the pins here. Now let's copy one of this pin, copy to clipboard, paste from clipboard. The RS and enable pins are connected to pin 30 and 31. So this is IO 30 and this one is IO 31. We have drag object to here. Okay, we have VEE as the this. This one will be grounded, this one will be grounded, and this one is connected to here. This one will also be grounded. Okay, let's check the ground here now. This is the ground. Wait, this one ground. We are supposed to put the ground here, and we're putting the ground here and here. Now that we have put the ground, the next is, because we are using a potentiometer to variate it, we will be using potentiometer on the output as well. So select the pot again, place it here, and after placing, wait a minute. Okay, let's place it here. After placing it, we need to connect a voltmeter, and we will find voltmeter here, DC voltmeter, between the ground and the input. And we need to select the ground. Here is the ground, place the ground here. After this, the output pin that we selected is AD0 F pin here. This one, AF0, so it is AD0. Let's place the pin here. Now above we will, because it is said that the V reference should be 5-fold for the potentiometer variation, we will be using 5-fold at VDD and on here. So let's bring it here and connect it to the above sections. So we need to connect it to the ground. For that we need this. Okay, we connected it to the ground. Now we need to connect it to the positive terminal, and we need to connect this part to the positive terminal as well. Put this to 5-volt, and we are done. Now what we need to do is check the different values of ADC based on the change in potentiometer values, and we need to upload the hex file. Here we will go to the desktop, we save the file in the new folder. So this is the new folder that we created at the moment, this one. Go to debug and upload the hex file. Click OK and start the simulation. Okay, right now it is displaying the value 512, but you can change, as if we said that the minimum value for a 10-bit ADC is 1 and the maximum value is 1023. So when you move it up, the maximum value should come as 1023 here. Now in between you will get different values: 922, 819, 717. In the middle we will get a middle value which is 512, like this. So this is the overall task for today. That will be it for now. Thank you.